Okay, let's do this. Hey everyone, my name is Jeremy, and today I'm going to try to rewrite a little bit of code in Rust. Um, I'm going to start by telling you what the ultimate goal is, and then we are going to try to work our way through the code base and try to rewrite stuff. So what you are seeing on the screen right now is part of the Mozilla Firefox code base. Those are functions that are being used in the network part. As you can see, those are C++ functions with a little bit of pointer arithmetics and this kind of stuff. There's a goto here, and there are a couple of things that we want to have a look at. My ultimate goal would be to be able to rewrite these functions in Rustlang and then maybe submit a pull request to Firefox. So there are a couple of things that we first need to know about me. The first thing is that I am a terrible programmer. I mean, I forget stuff all the time. I make logic errors. It's pretty hard for me to just not make silly mistakes, which is the reason why I'm going to need proper tooling, like something that allows me to write tests, something that allows me to benchmark the functions to make sure I don't waste cycles, basically. And I'm going to need a language that's kind of pretty helpful with respect to that, which would be definitely Rust. So we are first going to have a look at the tools I'm going to be using, and then we are going to dive in to how to write tests in Rustlang, how to benchmark stuff in Rustlang, and then we will try to interoperate Rust and C++ code and benchmark it as well, of course. So the first part, that would be the tooling part. There are a couple of tabs here which we are going to go through. The first thing I would like to tell you about is this Google test framework, which is, of course, developed by Google. Basically, it is something that allows you to write unit tests. Unit tests are very interesting because it allows you to know if the code behaves the way it is supposed to. I am gonna look through that. Maybe there are a couple of examples. Basically, there are expect and assert stuff. Assertion allows the code to crash if what is in it is not true. Basically, we are gonna write tests, expect things, and get a result. I'm gonna show you that pretty soon. The second tool I want to tell you about, apart from Google Test, would be Google Benchmark, which is another tool built by Google, and it allows you to measure how fast the code runs and sometimes figure out bottlenecks, figure out if there is anything that is not supposed to behave that way. Maybe it's supposed to work faster or something like this. So basically, we're going to try to figure out how Google Benchmark works, how Google Test works, and what are the equivalents in Rust, basically. Another thing I would like to show you, but I don't know if I'm going to be able to make it this far, is how to do that in Rust and how to interoperate between C++ and Rust. But let's first have a look at the bencher and the tester in C++. So as I told you, I am not a C++ developer. I am pretty bad at it, but I've been able to kind of figure out how to write a little bit of code and a small test and a small benchmark to it. There you go. I'm going to switch to the code here. and I'm going to tell you a little bit about the function. So I started with something very easy, which is a Fibonacci sequence. Uh, I'll let I'll probably display a link somewhere in the show notes to if you want to dive in a little bit more. This is basically the worst approach to the Fibonacci sequence because it's a pretty slow one. Um, Here, basically what it does is figure out if the number that has been input is less than 2. If it is, then it's going to return it. And if not, we're going to compute the Fibonacci. So the same function for n minus 1 and n minus 2, and we're going to add them together. So it's a recursive function because if you input something like n equals, I don't know, 10, then we are going to start here, go to the else, and then figure out that we want to compute the Fibonacci sequence of 9 and of 8. And of course, the Fibonacci sequence of 9 we would just basically step right in here and have to compute the Fibonacci sequence of 8 and of 7. So we are computing stuff all the time and computing things sometimes twice or even more. There are many other approaches to compute that much faster, but it's not what I'm trying to tell you about today. I'm trying to tell you about how to write tests in C++, how to write tests in Rust, and how to benchmark your code. Here you go. So what I'm going to show you is basically a simple test file leveraging Google Test. Here it is. So there's a bunch of include statements here that you would actually need to uh, figure out on your own. I suppose you need to install it on your computer. If you cannot install it, please leave a comment somewhere or let me know. Maybe I'll just make a video and tell you about how to use that. So basically, we are trying to include the test suite and the test framework from Google, and then we are going to write a test. Now, a test is a suite of 3 steps. There is a setup phase where we actually set up the context of a test. There is a run phase, which is where the code is actually being run, basically. And there's an assert phase. This is the assert phase, where after the code has been run, we want to make sure it did behave the way we wanted it to behave. So here, for example, I'm just writing code, letting it know that if there's a number that it's named n, the Fibonacci sequence of 40 is supposed to be this huge number. I don't even know how to say it in English, so let's keep it that way. So this is the expected result. I have computed it on my own using an online website or using other tools. And then I'm going to just run my code and make sure that the actual result is the expected result. If it is not, that means either my test is wrong or the code is wrong. And since my ultimate goal is to rewrite C++ functions in Rust, I want to make sure that the C++ code and the Rust code behaves the same way. So how am I going to do that? If I have no idea what the code does, I'm just going to give it a series of inputs, figure out what the output is, I'm going to save it somewhere, and I'm going to run the exact same test on the Rust code. If it behaves that way, I'll feel more confident pushing code. Okay, so I'm not going to run it right now. We're going to see it a bit later. What I'm going to do is tell you a bit about the bencher. Now, the bencher is something a bit, it works in another way. The other way is it's going to perform a computation a huge amount of time, and it's going to basically divide the total duration of the program execution by the number of loops that have been made. There's a couple of things that ones need to handle, which is the benchmark do not optimize here, but we are not going to dive into it right now. You can find more documentation. I'll add links to the show notes, basically. So what I'm going to do here is I'm going to input a number, which could have actually been random, but we would make sure that it's always the same because that would allow us to measure correctly. For example, it's pretty faster to compute the Fibonacci sequence of a low number like 1 or 2 because I'm gonna go back to the code. If it's less than 2, then we're just gonna return n. There is no recursion involved. It's gonna be pretty fast. So if we want to benchmark and make sure that the performance is actually good, we want to make sure we're not just giving it some random input. We want to make sure that we have the same test suite when we are running it. So as you can see here, I am benchmarking the CPP Fibonacci sequence, which is basically the one I've shown you, and the Rust Fibonacci sequence, which you haven't seen yet. We are going to dive into it later. So I've made a couple of helpers and a makefile. I am terrible at reading them and writing them. So through a lot of trial and error, I found this kind of suboptimal way to do stuff, but we're going to use it. Basically, what I'm going to do is I'm going to make clean and then make test, which is going to basically run the test. So, and make bench, which is going to run the benchmark. So the make test right now that I've written, this is actually the output of this code that is being run. As you can see, the test is named Fibonacci Fib40, which is this one. And it's running a test. There's a total duration, and it passed, which is great. You know, if I just made a mistake, or if the expected result is another, if I run make test, it's gonna fail. So this is a way for me, once again, I'm a terrible programmer. This is a way for me to make sure that the code behaves as intended. So I'm gonna write tests, make sure it works, try to refactor stuff, which is basically trying to rewrite it, and make sure it still works, okay? So I'm gonna put it back in. Tests are passing, I'm safe, I can move on. And the second thing I wanted to show you was the bencher. So I'm gonna make bench. I'm not really sure I wrote bench. Yeah, that's what I wrote. So here, there's a bunch of information like, oh, and there's a warning. And basically that's what I've been telling you is like, how long does it actually take to run the functions? As we can see right now, the rustling function is not as fast as the C++ function, but it doesn't matter for now. I just needed you to make sure that you understand what's going on right here. There's the rustling part that I would like to show you about. So I'm just going to dive to the second part of the workspace. There are two parts, which is the lib and the bencher. So I'm going to dive to the bencher, to the lib part right now, which is basically the way I write and expose rustling code to be used in the C++ side. So I'm not sure you are really familiar with rustling, so I'm gonna try to let you know what's going on actually. So there's a lot of boilerplate code which has a lot to do with the way we actually expose code to C++. So I'm just gonna show you about the slow Fibonacci sequence. Let's actually compare it to the C++ code. It's actually pretty close to it. This is the input, which is n. This is the output type, which you can see here, which is supposed to be an integer. Here it's an integer 32. If n is lower than 2, I'm going to return n, and else I'm going to compute the Fibonacci sequence of n minus 1 and n minus 2. And so the next question is, how do I write test to make sure that this function behaves the correct way? Well, there are actually two ways to go about it. The first one would be to write one in Rust. So I'm just going to create a module, which is here, which is called test, and add this directive here to let the compiler know that this is actually a test. And I'm going to make the exact same test as in C++, testing the Fibonacci of 40. This is the setup phase, where I create n and the expected result, which is the same. This is the run phase, where I actually run the Fibonacci sequence. And this is the assert phase, where I make sure that the expected result is the actual result, or the other way around, that the actual result is the expected result. And if not, I want the program to crash, basically. And I even added a little bit of context, which is not required, but it sometimes might prove useful. So there are several ways for us to run it. I'm gonna go to the lib directory. Maybe I can switch that off. Okay. So here are the two folders I told you about. There's the bencher and the lib directory. I'm going to the lib directory, and I'm gonna leverage the power of cargo, which is the basically the package manager, and it wraps the compiler for Rust code. I'm going to leverage it to run the test. So there are several commands that are being needed. The first one would be cargo build, which actually compiles the code. What I'm looking for right now is cargo test. Cargo test is going to build and run the test. As you can see, it says running one test, test passed, which is good. And the test is test fit 40, so that's the correct one. Again, if I just, let's just try to change the code here instead of changing the output. If I just change the code because, I don't know, maybe me in 6 months, I'll be looking at the code and I'll be like, what have I done? That's not supposed to be working, etc. And I'm about to push stuff and I'm about to put it in production. I just run the cargo test, boom, it failed. So that's kind of a safeguard for me as I write code, and that's even a safeguard for other people or for a future me, because I'm going to make sure that my tests always pass. So I'm going to just write it back in the correct way and run the cargo test again. That's good. Okay, now that I have it, I have been able to write and have a test pass in C++ and in Rust. There's a last thing that we have seen in C++, but we haven't seen in Rust, which is the benchmark. I'm going to show you a little bit about the benchmark. Here you are. Let's not split that anymore. We don't need it. Okay, so this is a benchmark. It might feel a bit weird at first, but in order to build the benchmark, I have added a library, which is actually called Bencher. Bencher can be added by added this line here to the dependencies in your cargo toml. For those of you who don't know cargo toml, it's basically like package.json in JavaScript. So it's the place where you tell about the dependencies of your library. So in the cargo toml, I actually added Bencher, and there's a couple of other things that are supposed to be written, which are displayed here. And I haven't made it up myself. I actually went to the Bencher crate documentation, which is great. I'm going to add a link to it in the show note. And it basically tells you everything that you need to know on how to set up the Bencher, how to use the Bencher, and this kind of stuff. So basically, this is almost copy pasted from the bench crate, and here you can see that there is the Fibonacci sequence again, which I have written, and there's like a benchmark. A benchmark takes a bencher, and there's this iter function that basically loops over stuff. It seems a little bit like the while state keep running that you have seen on the Google Bench site. So while it's running, let's compute this low Fibonacci sequence of, so I've written 30, but I've actually started with 40. So here you go. Now, once we have this, it's about to compute stuff. It's not about asserting stuff. It's just about running it a lot of times and figure out how long it takes for one function to be run. So how do we invoke that? We're going to invoke that using cargo bench. Cargo bench did compile the code again, and it said that it's running one test. So it's running a test. Hopefully it doesn't take too long. The problem with the Fibonacci sequence is that given this code is really not optimized at all, it kind of grows in an exponential time. That means it takes twice as long for one, every time n gets incremented by one, it takes like twice as long, which is not true for this example, but yeah, for 30, it was actually correct. For 40, it's really hard. As you can see right now, it took quite a bit of time. Those are my seconds, 70 seconds, which might be correct. And as you can see, for 30, it takes Okay, so that's a huge difference, as you can see. But that's not the problem. The problem was for us to figure out how do I test stuff and how do I measure stuff. Okay, so once we have a proper way to test things and a proper way to benchmark things, there is one last thing I wanted to tell you about before we actually have a little break and then start diving in. The last thing was how to make those things interoperate. As you can see here on the right-hand side in the bencher function, I am actually invoking Rust code from my C++ code. So there must be a way for me to compile things and to link them together and make sure that they are usable. So here's how I went about it. I went about it through a lot of trial and error, but given the documentation of bindgen and cbindgen and these kind of things, it's actually pretty straightforward. So here's the empirical way I actually figured it out. The first thing we are going to need as C++ is an include directive. We want to figure out somewhere where the interface is and which code we can invoke. So I basically wrote, I'm just gonna delete it. Yeah, sure, no problem. So this is basically the definition of the library I am building. It uses extern C that says that it's going to interoperate with C ABIs. And I might need to go a little deeper about the CABI later if I have a bit of time. Anyways, I'm going to tell you that I want it to interoperate with C or C++ code, basically. That would be C. And I'm declaring the Rust Fibonacci function, okay? And once I'm done, in the library, I'm going to split it. There you go. I'm going to split it. So here I am doing quite a lot of boilerplate. I'm writing stuff that lets us know that this is supposed to be exposed as C code, as if it was C code, basically. And I'm going to write a Rust Fibonacci, which is the same name. I'm going to write a Rust Fibonacci function, which takes an integer as a parameter and returns an integer. As you can see, there are some weird types involved here, and there are some kind of directives here. We are gonna try to figure it out. There's one thing I need to know. Maybe it works without cargo check. How does it go? It seems to be working. I probably don't need the lifetime here. This is boilerplate from other code I've been using, which had to handle strings. And it was kind of harder. Maybe we'll dive into it later. So anyways, now we have a function that computes the Fibonacci sequence, and it has been exposed as something that can be called from anything that uses the CABI. There's one thing that's very important here. This is the no mangle directive. Basically, when you compile Rust code, the function names are going to change. It's going to be something using the full name, like the crate name and the function name and this kind of stuff, plus a couple of, let's say, random characters that allow each function to have a unique name. The problem with that is that in C++, if you want to invoke a function that is in another library, you need to figure out its name. So the no mangle here is a way to tell Rustlang, no, I don't want you to change its name. It's supposed to be called by its name. So you wanna keep it that way. And another thing that's interesting is the crate type. The crate type is basically telling Rustlang what kind of library I want to write. I could write a static lib, maybe a dynamic library, or anything else. So basically, those are the two or maybe three things that are important on the, I'm not sure I need the student. Anyways, I'm going to figure it out later. So those are the two or three things that are important in order to write Rust code and expose it to the CABI. And there might be one last thing. Yeah, here, as you can see in the cargo toml, I have explicitly said that the crate type is a static lib. I don't know if I need to put it on both sides, but anyways, that's what I did and it works. I need to maybe check it a little more. All right, so right now, what's gonna happen, I'm gonna cargo clean. So cargo clean is the command that clears the target. As you have seen, there's nothing more. There's the RLS, which is a kind of a helper for Visual Studio Code, but there's nothing left in the target. I'm gonna cargo build here. Okay, I'm gonna build in debug and I'm gonna build in release. There you go. Let's go to the release. And here, there's a couple of nice things that are here. There's a .a, a .d, a couple of dependencies which we don't need to have a look at. And here are our libraries, basically, as you can see. So what are we going to do with those libraries? We are going to go back to the bencher code. And in the bencher code, we are going to tell the compiler where the library is. So here in the makefile, I'm sorry, it's very ugly. I am totally awful at writing that, but I hope you can figure it out or maybe fiddle with the code a little bit. The benchmark here has include paths, library paths, and library names. As you can see, there's the L benchmark, LG test, which are the two libraries that allow us to benchmark and test our Rust code. And oh, the coffee machine just stopped. That's cool. So there's like that's the way we kind of include both. So the benchmark and the test phase. And there's even this LRIIR, which is lib rewrite it in Rust, basically. And we are telling it that it's supposed to be in lib include for the definition and lib target release for the library file, basically, which is here. So once we've built it, we can link the C++ code with the previously built library and use it as regular C++ code. And this is what we did here. I'm going to go back to to the bencher. And in the bencher, I basically include RIIR, which is here. And I can invoke the code, the Rust Fibonacci, without any issue right now. So since it's a pretty hard stuff to kind of figure out on our own, I've kind of written a makefile that allows me to make clean, which is here. So I basically go to the library folder and cargo clean, and then remove the opt files that I've written in C++. And then there's a make build and a make, basically, and a make bench and a make test. So make test is here. Oh, where am I? Oh, I'm not in the correct folder. So make clean. There you go. Make bench. That's gonna build everything again and run the benchmarks and a make test, which is here. There is something that could be actually interesting, which we haven't seen right now. It's that, as you can see, the make bench and the make test functions, maybe I'm gonna move it to the right so you can see it hopefully a bit more. So here, when I run make test, I just run basically the Google test tool. And when I run make bench, it also just runs the benchmark tool. So maybe it would actually be convenient to run the Rust tools and run the Google tools at the same time. So basically what I'm gonna do here, I'm gonna copy paste my way through it because I really am not good at all. What I want to do is from the bencher folder, I want to go to the library folder and then invoke cargo bench. And then I want to go back to the bencher folder and run the bencher. And the same way, what I want to do with the tests is go to the lib, run cargo test, and go back to Bencher and run the tester. Let's try to see if that works. I'm gonna make clean. I'm gonna make test. Oh, so I failed, basically. Let's try to figure out what happens. I'm in the Bencher and cargo tester. Okay, that's a typo. And cargo test, that's what I wanted to do. Build, run the test on the Rust side, build the C++ side, run the test on the C++ side. And I want to make bench to figure out if both benchmarks are being run. Oh yeah, it takes a while. I forgot about that. Anyways, I want to make sure that both benchmarks are being run. And if it actually works, then that means we are good. We are good to go. We are good to start writing stuff and rewriting some nice C++ from the Mozilla Firefox code base in Rust, which I'm gonna show you right then. So if you wanna actually try it out at home, I have, oh, there you go. Awesome. So I've been able to run the test, run the benchmark, sorry, run the benchmark on the Rustlang side and on the C++ side, which is exactly what we wanted to do. There is probably a last thing or two that we could be doing, which is try to write a test that actually tests our Rustlang code. Let's try that. There's a test CPP, and I'm going to write another test, see how it works. That 2 plus 2 is 4 in Rust. So what I'm going to do here is I'm going to try to invoke Rust Fibonacci. Rust Fibonacci is supposed to behave the exact same way as the CPP one. So with the same input, I'm supposed to have the same output. And what I wanted was to include RIIR.h. As you can see, there's no more red squiggle under the Rust Fibonacci, so it kind of feels good. Another thing I want to do is that it's FIB40, that would be CPP FIB40, and that would be Rust FIB40. Let's try the make test again. Oh, that's awesome. I think I got pretty lucky. So anyways, the tests have been run on the Rustlang side. A test has been run on the CPP side, and I have been able to invoke my Rust function from C++ and assert that it behaves the correct way. So this is basically what we are going to try to do while rewriting things. We are going to write a Rustlang function. No, we are going to write tests on the CPP side. We are going to write a Rustlang function, have it pass the same test, and then invoke it from the CPP side and make sure that the tests are still passing. And once it all passes, we are going to try to reason about the complexity of the code and how long it takes and the performance. We first want to make sure the code is correct and then make it fast, not the other way around. And as you can see, I've written a little bit of documentation. There's a lot to understand with respect to documentation. The documentation in Rustlang is awesome. It basically can also behave like a test and compile, which means your documentation is always up to date, but we might want to have a look at this in another video later. All right. So yeah, there's one last thing I wanted to tell you about. If you want to try that at home, you need to, of course, install Google Test, Google Perf, which is not really easy if you are not used to C++ and linking and building stuff. So let me know in the comments if you have been able to make it. If you can't, then I'll probably record another video trying to show you how to do this. And since that's a lot of boilerplate, I would like you to know that I have actually been able to publish this rewriting in Rust crate, which I'm going to show you right now. So there's basically no README, no license. I'm probably going to add it afterwards, but this is the whole code that might be useful for you to try to figure out how it works and this kind of stuff. The lib side, which is Rustlang, is going to compile and run probably seamlessly. The bencher side, on the other hand, has a makefile here with include path and a couple of weird stuff in the makefile. So you want to make sure that you are using your own folders for the L benchmark and LG test. It's actually in user local include and user local lib on my distribution. Might not be, depends on where you install it. You want to make sure that you link it here before you try to run it. If you run into any trouble, let me know. I would gladly help. And if you have any question with respect to basically anything, I'll just drop me a comment and I'll just try to do my best to answer. And if not, I'll gladly try to figure it out so you don't have to. Thank you very much for watching. I'll be back shortly with the next step, which would be starting to actually rewrite a couple of functions in Rust. I hope you enjoyed it and see you.